Good morning, this is Dr. Turner for Integrated Math 2. Today we're focusing on lesson 2.2, which is adding polynomials. 2.1, we focused on classifying polynomials. We'll also define what are like terms, what does that look like. So if you need a little bit more practice on that, go back and watch the 2.1 video. But today what we're focusing on is adding polynomials. So to add polynomials, the first thing that we need to be able to do is recognize what are like terms. This is something that we throw around a lot in Integrated Math 1, Math 8, all the way down when you start, even down to elementary school, like what are like terms? So if you're doing this in elementary, it might be something simple of just collecting things, right? You have put all the squares or the rectangles together and then put all the circles together. How many of each do you have, right? That's a pretty basic elementary concept. The same thing applies when we're looking at algebraic terms, is we're collecting the same thing. So one important distinction to make is that in algebra, terms have to be either the same degree or the same variable, which means that if I have something like 3, 5, 7, 24, those are all numbers, so those I can combine. And remember that the focus of this section 2.2 is the addition and subtraction of like terms. So if they are like terms, then I can add or subtract them. Similarly, if I have any combination of x's, let's say 4x, 7x, 1/2x, all of those are like terms. But when I get into variables, the key component is that they are the same degree, they're the same power. Because while x's are a like term, x's and x squareds are not. X's and x squareds are different terms, and that gets a little confusing. A lot of students struggle with that concept, but x's and x squareds are not like terms. So if I asked you to combine some combination of these things that are on the screen, you cannot combine x's and x squareds with addition or subtraction. They are different. So however you need to remember that for your notes, make a note of that. X's and x squareds are different. And that goes for any variable, a's and b's, a squareds and b squareds. They are different terms. So very simple problems, kind of at the beginning here. If I'm looking at something, let's say I'm combining binomials, which you remember is two terms. So if I have something like 3x plus 4 plus 6x plus 1, for instance. Sometimes you'll have the parentheses, sometimes you won't. There are different techniques to this. Some people like to highlight or color, which is fine. So what I would do is I would go through and say, okay, well, those are all my x terms there. And then using a different color, those are all my constants, my numbers without a variable there. So you would simply just combine those like terms. 3x plus 9x, or 3x plus 6x is 9x, getting a little ahead of myself there. And then 4 plus 1 is 5. So that is the addition of polynomials. The name is a little bit scarier than it sounds. That's all you have to do. Some people, and to give you another example here, 4x minus 3 plus 7x minus 2. Some people like using shapes, which is fine. So if you're doing this by hand, maybe you put a box around all the terms that have an x, and then put a circle, being careful with signs, around all the constant terms. And then you just combine each of those differences. So 4x plus 7x is 11x. Negative 3 plus negative 2 is negative 5. Another technique is what's known as vertical addition, and you've seen this before. 7x plus 12 plus 4x minus 6. Now, vertical addition is a good example of what to do if you have more either complex terms, or if your two polynomials don't have the same number of terms. It's a good idea to do vertical addition, but it works just the same. So for instance, if I want to do this, 7x plus 12 plus 4x minus 6, I might choose to do vertical addition. So when I'm doing that, what I'm doing is I'm making sure that all the like terms are lined up. So in this case, all my constants are lined up, right? On the right, 12 and negative 6. And then my x terms, or my linear terms, are on the left, 7x and 4x. Once I do that, I'm going to add straight down to get 11x plus 6. Okay. Subtraction is the same way, but let's add, let's do a trinomial instead of a binomial. So let's say I have 3x squared plus 10x plus 12, and I'm going to subtract x squared plus 4x plus 10. Okay. So again, up to you. If you want to use the vertical addition, you can. That's the method that I prefer, but if you also just want to group your like terms, that's fine. So you have 3x and x squared, you have 10x and 4x, and you have 12 and 10. Remember, you are doing subtraction here. So some people will take this negative and they'll go ahead and distribute it so that they don't forget. But that's up to you. It's a matter of preference. Just remember what operation you're doing here. We are doing subtraction. So I do 3x squared minus x squared. That's 2x squared. I have 10x minus 4x. That gives me 6x. And I have 12 minus 10, which gives me 2. Okay. Be careful with positives and negatives. And if that's something you're still struggling with, I recommend that you just double check your work using a calculator. Because here we were doing all terms where I ended up with a positive number instead of a negative potentially. So let's say I had negative 5x squared minus 6x plus 10 minus negative 3x squared plus 4x plus 5. Right? Same process as before, but now I have positive and negative numbers, and that throws a lot of students off, so you want to be careful with that. Remember, math is cumulative, so anything that you've learned prior to this section is considered fair game. But we're going to do the same process, negative 5x squared, and again, I'm doing minus a negative 3x squared, negative 6x minus 4x, and then I have 10 minus 5. Again, we are doing subtraction here. So very carefully, negative 5x squared minus a negative 3x squared. And if you're subtracting a negative, that becomes a positive. So negative 5 plus 3, that gives me negative 2x squared. Negative 6x minus 4x, same sign. So add the numbers, keep the sign, negative 10x. And then 10 minus 5 is 5. I mentioned earlier that when you're doing these combinations, if you're missing a term in one of the polynomials, sometimes it helps to do the vertical addition or subtraction. So this is what I meant by this. Let's say I have 4x cubed plus x minus 6, and I'm going to add 2x squared plus 7. Okay? So I can still combine these, but remember that I can only combine like terms. So when I go here, and let's say I was doing the highlighting method or the shape method, here's 4x cubed. Well, there's no x cubed in the second polynomial. So that just means that my addition is going to be 4x cubed. And then go through with a different color. I have x, but no linear term in the second one. So again, that one's not going to change. I have minus 6 and a 7. Okay, so those I can combine. And then I'm left with 2x squared. No x squared term in the first polynomial. So when I combine these, we are going to get, when I combine these, we are going to get 4x cubed plus 2x squared plus x plus 1. My recommendation is that you do the vertical addition when you have polynomials like that. So let's say I have 3x to the 5th power minus 6x squared plus 2x plus 7, and let's do plus 2x to the 5th power plus 3x to the 4th power minus 7x. Okay. So if I'm doing this, I'm going to try to line it up, and anytime that there is a gap in my polynomial degree, I'm going to leave a space. So I have 3x to the 5th power. There's no 4th term, so I'll leave a little gap here. There's no cubic term. And then I have minus 6x squared plus 2x plus 7. Okay, then for the second term, I have 2x to the 5th, so I'm going to line that up here. I have 3x to the 4th power. Put that here. There's no cubic term, so I'll leave a space. There's no x squared term, so I'll leave a space. Minus 7x, and then there's no constant term. So again, the goal is to line up all the terms. So 3x to the 5th plus 2x to the 5th. That's 5x to the 5th. 0 plus 3x to the 4th power. Minus 6x squared plus 0. 2x plus negative 7x. And then 7 plus 0. So that's all there is to this section, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you later.